In our last class, we have learned about different types of velocity. Today we are going to learn different types. In our last class we have learned different types of speed. Today we are going to learn different types of velocity. Okay. First of all, just like uniform speed, there is uniform velocity. What is uniform velocity? If a body moves same equal distances in equal interval of time without changing its direction. That means the displacement should remain the same, the direction of the displacement should remain the same, and the magnitude of velocity should remain the same. So velocity, uniform velocity means magnitude and direction both should remain the same. So uniform velocity means magnitude and direction both should remain the same throughout the time. So uniform velocity is defined as if a body moves equal distances in equal interval of time without changing its direction, then the velocity of the body is said to be uniform velocity. Now, what is non-uniform velocity? If either of magnitude or direction or both change with time, then the velocity of the body is said to be non-uniform. So, in case of non-uniform, either magnitude changes or direction changes or both of them change. Okay, so this is non-uniform velocity. Just like in case of a non-uniform speed, we determined or we found out average speed. Here we also determine average velocity. What is average velocity? Average velocity is defined as the ratio of displacement to the time taken. Average velocity is defined as the displacement to the time taken. So here we find net displacement and the total time. Okay, net displacement unlike the total distance traveled in average speed. So net displacement can be calculated by vector method. So net displacement can be calculated by vector method. Now next topic is instantaneous velocity. Instantaneous velocity. Instantaneous velocity may be defined as the rate of change. Instantaneous velocity is defined as the rate of change of position vector of particles or of a particle with time at a certain instant of time. At a certain instant of time. So instantaneous velocity V bar is defined as limit delta t tends to 0 del r vector by del t. So it may be written as dr dt. So is the concept of calculus. Obviously we have studied in calculus what is ddt. So dr dt is the rate of change of position vector. Rate of change of position vector. Our next topic is acceleration. Acceleration. What is acceleration? Acceleration is the rate of change of velocity with time. So acceleration equals to v by t or del v by del t, or it may be written as dv dt when del t tends to 0. Acceleration is a vector quantity, so we can also write like this. Now acceleration can be of two types: uniform acceleration and non-uniform acceleration. Okay, acceleration can be of two types: uniform acceleration and non-uniform acceleration. What is uniform acceleration? Since it is a vector quantity, just like uniform velocity, if its magnitude and direction remain same throughout the motion. So this type of acceleration is called uniform acceleration. And just like non-uniform velocity, same thing happens here. Either magnitude changes or direction changes or both of them change. Now, this type of acceleration is called non-uniform acceleration. Now we are going to study different types of position time graph. Different position time graph. This is very important for the competitive exam and also for school exams. This is time axis and this is position axis. We see that the position of the body is not changing with respect to time because the straight line is parallel to time axis. So position is not changing with time. So from this we conclude that theta equals to 0 degree. Therefore V equals to 0. Why V equals to 0? Because V equals to ds dt, change in position by change in time, equals to 0. So the particle is at rest. So the particle is at rest. This is number 1. Now number 2. The graph is parallel to position axis. Here theta equals to 90 degree. So V equals to ds dt equals to, better to say this slope is tan theta. So tan 0 degree equals to 0. This is equal to tan 90 degree. So what is the value of tan 90? Infinity. That means line or better to say the particle possesses infinite velocity. So the particle possesses infinite velocity. Number 3. So theta equals to here, theta equals to constant. That means theta is not changing, it has a particular value other than 0 degree or 90 degree. So V equals to tan theta has a particular value constant. Since V is constant, acceleration equals to 0. So there is no change in velocity. So v is constant here, acceleration is 0. That means the particle is moving with constant velocity. So the particle is moving with constant velocity. Graph number 4. Position time graph. Position time graphs. This is graph number 4, and this is like this. So here theta is increasing. So v is increasing and acceleration is positive. So acceleration is positive. So it means that the particle's velocity is increasing and it has some acceleration. So in the previous example, acceleration was constant, acceleration was 0 because the velocity was constant. Now in this example, velocity is changing, it is increasing, therefore it has some acceleration. In this graph, what is happening? Theta is decreasing. Theta is decreasing. Therefore, V is decreasing. So, acceleration is negative. So acceleration is negative here. So acceleration is negative means the particle has retardation. The particle has retardation. Graph number 6. This is theta. And we know that what is theta? Theta is the angle that the tangent of the graph makes with the x-axis. So this is the x-axis, our time axis, and this is our position axis p. So in this case, theta is greater than 0 degree, theta greater than 90 degree. So v is constant. Therefore, v is constant, but negative, because v equals to tan theta, theta greater than 90 degree, so v is less than 0, that means v is negative. The the figure shows that the particle returns towards the point of reference. This is the point of reference, and the particle is moving close to the point of reference and then moving away. That means the displacement in this case, this particular portion, the displacement becomes negative. So the graph has some positive displacement and some negative displacement. So learners, these are the normally main graphs for position time graph. You have to learn all these things for your exams. If you like this video, then please just press the like button and subscribe my channel to get more videos. Thank you for watching this video. Please subscribe my channel so that I can improve my arrangements. Please subscribe my channel. Thank you.